Okay, we looked in a previous video at simplifying surds, and in this video we're going to use that skill when we're presented with sums with surds in, calculations with sums in. Over here I've got the square root of 12 plus the square root of 75. Remember that if we were to do that on a calculator and work out the decimal answers to the square root of 12 and the square root of 75, which we could do, we'd have a long decimal answer, but it would be an approximation because these are irrational numbers. We wouldn't be able to write the whole number down. So we're going to keep it into surd form. Some calculators actually would do that for you, but it's useful for you to know exactly how the calculator is working. So let's start with the square root of 12. Square root of 12. We're going to split 12 up into two factors, which is 4 times 3. And if you remember from our rules of indices, that's the square root of 4 times by the square root of 3. Square root of 4, of course, is 2. So we've got 2 root 3. Now, I've dealt with the square root of 12 there, but we've also got this plus the square root of 75. Again, we're looking for a factor pair, and we're looking for a factor pair that includes a square number, because that's going to help us to simplify. So 75, that's 3 25s. So if I say 25 times by 3, which we can split as the square root of 25 times by the square root of 3. Square root of 25, of course, is 5. So 5 root 3. 2 root 3 plus 5 root 3. We're not quite done because if we've got 2 lots of root 3 and we add 5 lots of root 3, well, we actually end up with 7 lots of root 3. So our final answer is 7 root 3. And there's a sum with 2 surds in it. Over here we've got a slightly more complicated one. And we've got a sum with 3 surds in. How are we going to approach that? Let's have a look at the square root of 50 first of all. Square root of 50. We're looking for 2 factors including a square number. 2 and 25 are factors of 50. 25 is a square number. So that feels like it's a good place to start. We don't always know if it's the right place to start, but when we get a little further down the sum, we'll be able to see if things, if we end up with the same square root numbers, the same surds in the other numbers. So let's see how that goes. Square root of 50 is the square root of 25 times by 2, which is the square root of 25 times the square root of 2, which equals 5 root 2. Okay, let's deal with our root 8 now. Root 8, well, that is 2 times 4. So if we have the square root of, I'm going to write the square number first, 4 times 2, which is the square root of 4 times by the square root of 2, which is 2 root 2. Notice I've ended up with the same square. I've got root 2 in both, so I'm feeling more confident now. I think I'm on the right lines. Especially when I look up at our final one, which was just 3 root 2. Let's bring that down to each line, plus 3 root 2. Just like we did over here, we can look, because we've got root 2 is a common factor to each of these terms, and I've got 5 lots of root 2, subtract 2 lots of it, and add on 3 lots of it. 5 take away 2 is 3, add 3, 6. So I end up with 6 times the square root of 2.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.